Welcome to On the Road. I'm Andrew Cotter, Program Manager for the Cooperative Research Network. Today we're at Arizona Electric Power Cooperative in Cochise County, Arizona, and boy is it sunny outside. Today we're going on the road to their Apache power plant. Take a look at their multi-pollutant control demonstration that's going on right now. This test was the second in a series of demonstrations to validate new technologies to help electric cooperatives produce cleaner, affordable, reliable power. The first test at San Miguel Electric Cooperative successfully demonstrated the potential of enhanced mercury oxidation from Shaw Environmental to remove up to 90% of mercury emissions. This demonstration at Arizona Electric Power Cooperative's plant Apache tested two technologies: dry sorbent injection, also known as trona injection from Natronix, as well as the enhanced mercury oxidation, to see how these technologies work together.
The major goal is you want to remove all the constituents from the gas: SO2, SO3, mercury, and hydrochloric acid. So trona comes in, and trona, because it's a base, it will aggressively attack all the acids. But there's one other thing we talked about: mercury. Mercury is not affected by trona. And this is where our other hero comes in, EMO.
EMO is a technology that Shaw Environmental developed in order to enhance the oxidation of mercury within a combustion gas stream coming off of coal-fired boilers. The mercury is oxidized, allows to stick to particulate, and will then be scrubbed through the system before it goes out the stack.
How different is it running a power plant with EMO technology versus without the EMO technology? Do they have to change their operations, or is it just run things as normal?
For the most part, EMO does not require them to do any special operational changes to their coal feeds, to their boiler operations, or any of the main primary power generating operations. There may be some slight modifications in how they operate their air pollution control systems, but those are very slight. To date, all of our trials to date have shown that we've had little or no impact on any of the air pollution controls or the outfalls from those controls. Actually, we've had no regulatory impact on ash or FGD blowdowns or any of that technology's outfalls. Right now, this plant is operating at full load. They do not know we're even injecting when we are injecting, except they see the mercury control numbers go down. As far as working with the cooperatives, it's been very pleasant. We've had no problems whatsoever. Everybody here has been great. The plant operators have worked very well with us on our technology, but working with CRN on all of these projects has been great.
Our test measured the advantages of a unique environmentally controlled trona from Natronix. Our test showed that this process can provide a 10 to 15% increase in effectiveness over standard trona, especially in hot, humid climates. United Conveyor Corporation is in charge of handling the specialized trona from the mine all the way to the power plant injection.
The purpose of testing generally is to get a better understanding of the kinds of injection rates that we need to optimize those injection rates to get the performance that we want, the emission removal performance, and to also just show the plant how this technology works and show what the effects are on the overall plant, kind of the balance of plant effects, so that they get comfortable with the technology.
Let's walk through what's happening there and kind of the process that I'll go through.
You can see the truck. There's a blower on the truck that blows the trona into the top of the silo, and on top of the silo is a dust collector, so we're not causing emissions while we're filling. And then when the silo is full, we can start injecting, and then blows it back into the trailer, through the mill, and then coming out of the mill, there's a hose going up the side along the steel on the edge there, up to the ductwork, and then it goes into splitters, and then coming out of the splitters, it goes to the individual lances that are inserted into the duct.
Engineers from around the US and Canada came together to see the testing firsthand.
This particular demonstration is involved with numerous utilities, and that's unique because it really allows for a collaborative effort amongst all of the member utilities that are involved, and it gives an opportunity to demonstrate the technology during one test to a broad group of utilities at once.
It is profoundly important. The costs associated with some of the standard technologies are prohibitive for a company of our size. There's a potential here to meet the applicable standards in a way that is substantially less costly. And that's incredibly important for our members and for the customers that they serve. And so this kind of research, if it can open the door to maintaining a reasonable cost product, then it's important.
Just as in the San Miguel test, the enhanced mercury oxidation technology showed the potential for removing upwards of 90% of mercury emissions. In addition, Trona showed the potential of removing over 50% of acid gases. Together, these technologies show great promise not only outperform the standard technologies of today, but to do so at a cost many times smaller.
This is going to provide a lot of G&Ts that do not have scrubbers with a lower cost capital option for meeting the requirements of MATS and CSAPR. This will keep more plants in operation burning coal, whereas if they're forced to put selective catalytic reduction systems or scrubbers, many of our plants will probably close down. But at the same time, we're going to provide options that can help plants that have SCRs and scrubbers already. It will provide additional removal of SO2 and acid gases if they need them. There are some scrubbers that have a visible plume, bluish or a white haze, due to sulfur trioxide. With a little bit of Trona injection, you eliminate that plume. So it'll have benefits for them. The hydrogen bromide, the enhanced mercury oxidation, can be added to a plant that has a selective catalytic reduction system, and for a small amount of money each year, take out arsenic and selenium, which foul the scrubbers up. So we end up with a boutique solution for any particular G&T, depending upon what kind of removal equipment they have. We're going to give them tools in a toolkit that they can apply to provide the lowest cost option, because our goal is what? Affordable and reliable electricity, and this will go a long ways to meeting that goal.
As a plant manager, can you talk to me a little bit about, if successful, how this technology might change the way you guys run your operations, or how this might just impact your job for power production?
Well, I think for power production, it would affect us that. I mean, if this is a technology that really does work, I mean, it might save you in the long run from a lot more expensive technology. I mean, what you're looking for is to be cost effective in the way you're producing electricity. I mean, we're not a very large cooperative, and so our members are really looking for us to get the most cost effective way to, do business here. So, I think there's some promise here. We just got to kind of work through the details and continue to do some testing with it.
What about the actual operation itself? Does it change the way the power plant runs, you think?
Well, I think that it would change a small portion of the way the power plant runs. I mean, we have a contractor that purchases all of our fly ash, so we have to look at all those issues. Now, that's not a large contributor to our bottom line, but I mean, we are in partnerships with people, so I want to make sure that, there's a possibility of that changing. There's a possibility of, I don't think there's much as far as performance-wise, but as far as internally to the furnace. But I mean, externally, you have to look at manpower requirements, if there would be a larger manpower requirement to us, and then, of course, with all the crafts. And so, I don't think there's a huge impact, but I think the impact, we'd want to review that impact and look at all the best possible approach.
Those cooperatives that contributed to the funding of this particular project and those that hosted it require special recognition.
In addition to Arizona Electric Power and San Miguel Electric as demonstration hosts, participant funders include Associated Electric, Great River Energy, Hoosier Energy, Sunflower Electric Power, Western Farmers Electric, Deseret Power, Tri-State G&T, and ATCO Power from Canada. Mark, your impressions from the demonstration so far?
Well, I think they've been very positive. I think what they're doing has been effective, and it's going to give us a low capital cost option potentially for control of some of the emissions that we're concerned about.
So if successful, you do see some potential for this to be applied at your electric cooperative?
Yes, we have a plant that we're looking at this particular technology as a potential solution, yes.
My impression so far has been the HPR injection works very well for improving mercury oxidation and overall removal, really. of Mercury. I think there's definitely the potential for us to implement some of this technology. We have an SCR, so we have some mercury oxidation already, but we may use it to increase a little bit further and improve our oxidation when our catalyst degrades.
We don't have necessarily the resources alone to solve some of these problems. And so it's important for us to get together, to use those resources collectively, to invest in R&D and to come up with solutions that are good for co-ops.
We are doing a study with an outside consultant right now to help us understand how we're going to meet the MATS requirements, the mercury and air toxics legislation. So this will help in our decision making for sure. For us, the research that CRN does is very important in this time.
As a cooperative, we are first and foremost looking for the lowest cost option to give us compliance certainty. So this was something that was very attractive to us.
That's a big plus of these systems, is that the capital cost is minimal, and depending on the situation, it may be a lot more cost effective to use a system like this where you're using chemicals instead of capital for your emissions removal. And I think it's worked well from a cooperative standpoint, where several G&T cooperatives came together and, working with industry, provided some funding, found demonstration facilities at San Miguel and here at Apache, and I think it's worked out real well. It has definite application for other situations like this, where a new product needs to be tested, needs a little bit of financing and host sites. So I think it's a great way to approach technology that may not come to market otherwise.
Now is the time that the cooperatives need to really pull together. There's large cooperatives, small cooperatives, but if you are a cooperative, you want to pull together. So I think anything that we can share with our fellow cooperatives is very important to us, as hopefully it will be to them. I mean, anything that we can collaborate back and forth on. I mean, if anybody's looked at the environment out there today and the political scene, now is the time we all need to come together.
Well, thanks for joining us here at the demonstration for the multi-pollutant control technology. This is a technology we feel can really help electric cooperative G&Ts not only handle many of the environmental pressures they're facing, but to do so in a very competitive manner. This demonstration couldn't have been done by ourselves. It took the help of many people, such as Arizona Electric Power Cooperative, as well as co-ops like San Miguel and their power plant down in Texas. There was a group effort with a number of funders, and together we're able to make this technology happen. For more information, go to cooperative.com/CRN and enter keyword MPC or multi-pollutant control.